Dear friends, I myself, Dr. Bharat Parab, discussing the topic direct and inverse proportions. Introduction of proportion. I have covered this in the same chapter while discussing direct proportions. I am refreshing it as if you are clear with these examples, then you will understand the difference between direct and inverse proportion. That's why I have taken the same examples and discussing it again. Okay. The word proportion itself means ratio. Consider these examples. These are the same examples we have seen earlier. If cost of 1 kg of sugar is rupees 30, then cost of 2 kgs has to be rupees 60. Very simple. We have seen this. Second one, if one container can hold 1 liter of water, then 10 such containers would hold 10 liters of water. This is again very simple. Okay. Look at the third one. If a car travels with a speed of 10 kilometers per hour, then it will take 2 hours to cover distance of 20 kilometers. Remember, this distance is constant for further part of the problem also. So if car travels with the speed of 10 kilometers per hour, then 2 hours will be needed to travel 20 kilometers. But if car increases the speed to 20 kilometers per hour, then it will take 1 hour for the same distance. Now remember, as speed increases, time decreases. This is very important. Here, as quantity increases, the price also increases, amount also increases. Here, container increases, then the capacity also increases. Okay. Here is the other way around. Look at this example again. Rupees 1000 are to be distributed amongst 10 students, then each will get rupees 100. Okay, 10 students 100. But if these are to be distributed amongst 20 students, then each will get rupees 50. Here number of students increases, amount decreases. Remember this thoroughly. Okay, so we see here in example 1 and 2, we observe that as one quantity increases, other also increases, other also increases. But in example 3 and 4, 3 and 4, one quantity increases, one increases, or one increases, other decreases, other decreases, other decreases. Okay. So in example 1 and 2 is a direct proportion, and 3 and 4 is inverse proportion. We will discuss inverse proportion in details in further part of this video. So this much was same as in the direct proportion video. Okay, so we move ahead for further study. Inverse proportion. We have seen what is a direct proportion, studied in detail and some examples on this. Now we are studying inverse proportion, and for this we are taking a help of example just given on the last slide. Just copied it down, then it will be very easy to understand what is inverse proportion. See the example, if a car travels with a speed of 10 kilometers per hour, then it will take 2 hours to cover distance of 20 kilometers. Okay. But if car increases the speed to 20 kilometers per hour, then it will take 1 hour for the same distance. Okay. Now this is very simple like that, but we have to explain this in a mathematical form so that it can be formula can be applied to another unknown quantities that is to be determined in the problem. Okay, so see, there are, this distance is constant, same distance, same distance. So what are the varying part is, one is speed and another is time taken. Okay, so answer, let us prepare a table for this given data and try to put this into a mathematical form. The speed of car is taken here, denoted by x. So x1 and x2, x1 for the first and y1 and y2, that is the time taken is denoted by y. So y1 and y2. The speed of the car was 10 kilometers. This, so that time y1 was 2 hours here. When the speed x2 is increased to 20, then the time taken was reduced to 1 hour. Okay, so this is very simple example to understand. So we will try to find out how this is related to the proportion, is called inverse proportion. Okay, you can see here, as speed increases, time taken decreases. It itself shows that there is something inversely going on. Okay, so we clearly see that if, as x increases, y decreases. Okay, so we say that x, we have seen this, what is the sign, this is varies as, but here 1 upon y, that means we call and this or read it as x varies inversely as y. Okay, x varies, that time when it was direct, was varies as y. We generally don't call the word direct, but here it is necessary to call that x varies inversely as y. Okay, or we have to introduce equal to sign, x equal to 1 upon y into k, where k is a constant, or if you take the cross multiplication of this, xy equal to k is constant. Therefore, if you take the x1 y1 values, x1 y1 is equal to x2 y2 is equal to k. So we come to the example in a formula. In this example, it is reduced to this: if you take x on one side and y on one side, after getting this, get x1 upon x2, x1 upon x2 is equal to y2 upon y1. Remember this very clearly. Okay, indirect, it is x1 upon x2 equal to y1 upon y2. Here it is exactly inverse. Okay, x1 upon x2 is equal to y2 upon y1. Therefore, looking at this formula very keenly and studying it is very, very important. Okay, so let us rewrite the above tabular form and apply this formula. Okay, we know we have got it, but we will still apply and check whether this comes out to be true or not. Okay, just for our satisfaction. Okay, so move ahead. We have seen the major part of this example in the previous slide. Now we will just check x1 y1 equal to x2 y2, whether this is correct or not. Substitute x1 y1, 10 into 2 equal to 20 into 1 is 20 kilometers, the distance. In all these four quantities, if any three are given, then fourth can be found out. Okay, so this is very important, and what is still more important is, don't make mistake in writing these quantities in a symmetric manner. Okay, check out for this, x1 and y1, don't do it the other way around. Okay, that is very important, and you will get this by solving many problems. Okay, So is a second example. Read it. Rupees 1000 are to be distributed amongst 10 students. Then each would get rupees 100. But if are to be distributed amongst 20 students, then each will get 50. So answer 2, represent this in the tabular form for rupees 100. This is constant. In inverse, there is something constant. In the above example was a distance constant. Here the money constant can see that there is something constant. Okay, and two other variables are there which are inversely proportional to each other. Okay, so number of students, if you take by x, x1 for the first one, and amount y1, so x1 y1 for the first one, and x2 y2 for the second one. But if you don't get x for students, then x1 will be student and x2 also will be student. This is very important. Okay, so let us form a table. Number of students here is x1 is 10, and here number of students 20. This is 100. Amount per student 100, and this is 50. When this is 20, this is 50. So let us check x1 y1 equal to x2 y2. Substitute x1 y1 equal to x2 y2. So 10 into 100 is equal to 20 into 50, that is 1000. This is for rupees 1000. Okay, so this is a concept of inverse proportion. We have seen what is direct proportion. We have seen problems on direct proportion. Now this is an idea of or concept of inverse proportion, and we will now try to solve some problems on inverse proportion, and you yourself try to solve some problems, and you will find this topic very simple topic. Okay, exercise first or first problem, very carefully. If a box of sweets is divided among 24 children, they will get 5 sweets each. Got it? Then how many would each get if the number of children is reduced by 4? Remember, each and every word has meaning in word problem in maths. Okay, see here the same box. If box of sweet is divided among 24 children, okay, and each is going to get 5, the box is same, shows that this is a inverse proportion problem. Okay, inverse proportion problem, we'll come to it. So answer, try to tabulate the given data as, see, for this we need to have, we have 24 children and 5 sweets, and another quantity we are asked to get how much sweets each will get. That means we must have a number of children in the second part. So it is given here. Number of children 24, and then number of children were reduced by 4. There is a meaning in this, reduced by 4. So 24 minus 4 equal to 20. Okay, so let us name these children as X, denote children, number of children by X, then X1 and X2. See, I was talking about reduced by 4. It must so happen that in another problem you may get reduced to something, to 10, reduced to 20, like that. Okay, so you should read it very, very carefully and try to understand the meaning behind it. Okay, so we were here, same box, same box. Okay, that means something is constant in this part and another part, unlike in direct proportion. So shows that this is a inverse proportion problem. So we prepare a table here, number of children 24 and x1, and we get 24 5 sweets, number of sweets divided by y for 24 is 5. Then in second case, number of children 20, then we have to calculate y2. Okay, as we know, this is an inverse proportion problem, so we use that particular formula, x1 y1 equal to x2 y2. Don't make confusion in writing this formula for inverse and for direct. In direct, it is, go and check what it is, x1 upon x2 equal to y1 upon y2. I'm not uh, repeating it again, so that you might commit some mistake after confusion. So you will let us concentrate only on this, x1 into y1 equal to x2 into y2. Okay, so let us substitute. We have x1 value, we have y1 value, x2 value. Okay, and we have to find out y2, this. So this goes in the denominator side, and if you cancel it, 5 1s are 1, and 5 4s are 20, 4 1s are, and 4 6s are. So y2 is 6, so 6 sweets each child would get. Okay, so this answer is 6. This 6 written after the calculations. Okay, so there such type of problems are literally very easy if you read this and try to find exact meaning of this and prepare this table correctly. So no problem. Okay, so you can move ahead with this. Second one, a farmer has enough food to feed 20 animals in his kettle. Okay, for 6 days. Okay, can you correlate this? 20 animals and dates. How long would the food last if there were 10 more animals in his cattle? Okay, so these are the two quantities. The food is, amount of food is same. So as something is same, it is to be, see, the food availability in cattle is same. That means this implies that it is a inverse proportion problem. Okay, so you can think of it. Now what are the four quantities we need? Animals and dates. So 20 animals. Let us prepare a table in answer. Prepare table for the data. Take X for animals and Y for dates. You can take anyhow you like, but you are taking animal X, then second also take animal X. Okay. So X1 is 20 animals. This is 20 animals. One. And Y1 is 6 days. Y1 is 6 days. X2 is X1 plus 10. Yes, 10 more animals were added. Okay, so X2 is X1 plus 10, that is 20 plus 10 is 30. When we have to find out Y2, then we have all this prepared, this table with this data. Preparation of this table is must, because this will remove all your confusion. So animals, X1 is 20 and y1 is 6. So x2 we know is 30. We have to calculate y2. So now we know that the availability of food is same. So it is inverse proportion. I was talking about this. So x1 y1 equal to x2 y2. Substitute x1 y1 x2 into y2. This is very important. That's why this is very important as well. And if you keep the data like this, you might lead to confusion and mistake. So write it like this. Do write it like this. Very easy to check whether there is mistake or this is correct. Okay. So see here y2 remains as it is. 30 should go down here to the denominator side. So y2 equal to 20 into 60, 20 into 6 upon 30. That is 0 0 goes, and this 3 with this 6 and 2 into 2 4 days. Okay, so this is 4 days. Got it? Very simple. Third one, this is very interesting. Read it very carefully. I think you should try such type of problems yourself and then look at the solution. Okay, a batch of bottles were packed in 25 boxes with 12 bottles in each box. If the same batch, there's something same. So you know what it is packed using 20 bottles in each box. Okay, earlier there were 12 in, now they see it is here. A, there are 12, then increase the size of the box and kept 20 bottles in each box. How many boxes would be filled? Naturally, you keep more bottles in a single box, then you will need less number of boxes as number of bottles are same batch. Okay, but we have to solve it in a proper mathematical way. Okay, so reading it, 25 boxes and 12 bottles, remember these two quantities, and bottles 20 bottles, and boxes we have to calculate the yellow one and green one. Okay, answer, represent the data which is given in tabular form as x1 is, because if you denote boxes by x1 or x, then x1 is 25 boxes, y1 is 12 bottles. Okay, can see there are 300 bottles. Here we have to find out boxes. So x2 we have to find out, and y2 is 20. Okay, a same batch implies that inverse proportion. Prepare a table of this type. See, not that always we have to find out something like y1 or y2. Here x2 has to be determined. So prepare a table. X1 is 25, y1 is 12, x2 we have to find out, and y2 is given as 20. Write this formula, x1 y1 equal to x2 y2. Very simple. You find it difficult only till here. If you have enough practice, then this is not at all difficult. Okay, if you are thorough with your funda, then they are definitely not difficult. Okay, x1 y1 equal to x2 y2. Here x varies inversely as y. Substitute 25 into 12 to x2 we have to find out, and 20. So do write this and keep these unknown as it is, because don't do it anything directly. Now take 20 down here to the denominator side. 25 into 12 upon 20. And now I think 5 fours and 5 fives, and here 4 ones and 4 threes. So 5 into 3 is 15 boxes. Okay, so x2 is 15. Okay, got it? It's very simple. If you don't understand, go through it again, with the try to solve the similar problems, then you will be thorough with it. Okay. Exercise 4. A school has 8 periods a day, each of 45 minutes duration. Okay. How long would each period be if school has 9 periods a day, assuming that number of hours to be the same? What is there is something same? So this shows that this is a inverse proportion problem. Now search for quantities and represent this in tabular form and then apply formula. Very simple. Read it. A school has 8 periods. See your answer. So tabulate given it as same numbers of hours. That is, this shows that this is an inverse proportion problem. Let x1, or let us denote periods by x. That means first will be x1 is 8 number of periods, and duration denoted by y1. Y1 is 45 minutes duration. Then if school has 9 periods a day, they increase the number of periods to 9, from 8 to 9, and naturally y2 will be little less. Okay, and we have to find out y2. So prepare this table. Number of periods by x, x1 and x2. Duration of the periods in minutes is 45, y1 and y2 we have to find out. Okay, so x1 y1, this is a formula for inverse proportion. X1 y1 equal to x2 y2. Here x varies inversely as y. Substitute. Very simple. X1 y1 equal to x2 and y2. So this substitution I told you in previous problem also, this is very important. So see that this is correct, or check it once again always, so that the here generally you don't make any mistake. Mistake can be committed here only. So look at it properly. Okay. So 8 into 45 equal to 9 into y2. So cross multiply, y2 will go, 9 will go here as denominator side. So 8 into 45 upon 9. If you 9 ones are 9 fives are, so 8 fives are 40 minutes duration of the period. You can even try with periods. We have taken x1, you can take y1 and duration x1, the other way around. But if you are taking periods in the first as y, then second also has to be y only, y1, y2. Okay, try it and find it. This will change, no problem. Your answer will be same. Okay, so move ahead. Some facts about variables increasing or decreasing together and need not always be in definite proportion. Something increases, something decreases. They do increase with time, but not in a definite proportion. Okay. So first one, physical changes in human being occurs with time, but not necessarily in definite ratio or definite proportion. As you may, for first 10 years, your height might be something, and then it suddenly increases. Not that every year it increases the same ratio. Okay, the physical changes in human being do take place, but not in ratio. Height and weight change in animals are not in any proportion with time or within the body. That means height increases, weight increases, but not by proportion. Not that first year you will have 1 foot or 2 foot like that. Okay. Third one, height of trees, branches, and number of leaves are not in definite proportion. On one branch may have more leaves, or one side of the tree may have more branches, and they are not in proportion. Okay, is something which is decreasing. Heat loss from a hot body to room temperature is also not in definite proportion. That is, if it is 1000, from 1000 it will come down to 900 within few minutes. From 900 to 800 it will take more time. Then similarly from 200 to 100 it will take still more time than all other intervals like that. But I have included this because a loss is not in the proportion but is exponential. Should know this, and we'll read about this in, or we'll study about this in higher standards. Okay, so do read this statement and be something in your mind about this. Okay, this is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of inverse proportion, let me know through comment section and I shall solve it. Thanking you. Good luck.